Dead zones are low oxygen areas in the world's large bodies of water caused by excessive nutrient pollution by human activity. In 2008, 405 dead zones have been reported. Dead zones are created by an increase in phosphorus and nitrogen in the water. This can cause an increase in phytoplankton, causing negative impacts through producing toxins and causing mechanical damage to organisms. These blooms cause damage to the ecology and are also linked to shellfish poisoning. Dead zones tend to occur throughout inhabited coastlines. However, areas in which naturally have no life present are not technically considered dead zones.
Ocean dead zones can be caused by an increase in nitrogen and phosphorus chemicals in the water. This can also be called eutrophication. The abundance of these chemicals can lead to an increase in certain phytoplankton. The abundance and density of the phytoplankton causes algal blooms. These algal blooms kill the local fish and other marine life. The resulting decomposition of the wildlife exacerbates the chemical balance in the body of water. Another cause of the ocean dead zones are chemical fertilizers that are man-made. Some natural causes of ocean dead zones are coastal upwellings and changes in the circulation of the wind and water in the area. Human sewage runoff or agricultural runoff can also cause nitrogen and phosphorus to become abundant in the body of water. Ocean dead zones can also be caused by the geography of the land surrounding the body of water. Bodies of water that are enclosed or have a small entrance can cause the water to become stagnant and not receive enough oxygen circulation. Deoxygenated water will also lead to the eutrophication of the water and the resulting algal blooms. Changes in the circulation of the ocean are also being linked to climate change and can lead to less oxygen being circulated by the currents.
Ecological effects. As the water heats up from climate change, there are more dead zones that are forming because of eutrophication. Eutrophication is how the underwater environment reacts to pollutants from runoff that come from the land and leads to the overabundance of nutrients, encouraging the overgrowth of algae. The algae overgrowth blocks the light from the sun, and the blocking of light is harmful to creatures underwater. Plants still go through photosynthesis underwater, and they also produce carbon for breathing. Animals need these plants to live underwater just as they do on land for oxygen. Because there is a lack of life, there is less oxygen circulating the ocean and therefore cause oxygen minimum zones, or OMZ, which can have a damaging effect on the underwater ecosystem. The algae that is most responsible for dead zones is called cyanobacteria, a type of algae that is allowed to flourish because of nitrogen and phosphorus material that continue to fill up in the ocean. This is a bacterial algae that is not beneficial to the ecosystem in any way because it is self-reliant and cannot be eaten. Fish suffer greatly from dead zones because the extreme changes in the oxygen level changes their entire biology. Their organs become smaller, meaning they can't reproduce or function in the necessary ways that allow them to flourish. The females are unable to produce as many eggs, and the males can't properly impregnate the females to keep the species alive.
Dead zone locations. Dead zones currently appear in areas where the human population density is high. This, of course, is a reflection of the waste we dump into oceans on a consistent basis. Today, roughly 245,000 square kilometers of our ocean is occupied by dead zones. Nearly 10% of that belong to the Gulf of Mexico, which is covered by 22,000 square kilometers of ocean dead zones. That's essentially the size of New Jersey. The United States and Europe contain the highest concentrations of dead zones. Most recently, mid-swept floods in the U.S. have largely contributed to the amount of nitrogen-rich water that has entered the Gulf of Mexico. Since the 60s, the amount of nitrogen that has seeped into the Mississippi River has reached upwards of 300%. It's for this reason that the Gulf of Mexico is not the most threatened body of water as far as dead zones are involved. This is especially frightening considering the fact that about 75% of the United States water flow, fish, and wildlife species highly depend on the 600,000 square mile body of water. Each region of the world has its own form of pollution that contributes to the dead zones that occupy its oceans. For example, some of the less than developed nations such as Latin America, Asia, and Africa dump untreated wastewater into its bodies of water. This is due to poor regulations and facility where waste is likely to build up and be disposed of improperly. The United States and Europe nations can allude to animal manure and commercial fertilizers as their main source of nutrients overflow into creeks, bays, and rivers that ultimately funnel into larger bodies of water, thus creating the dead zones that sit along its coast. One of the first known ocean dead zones was discovered in the Chesapeake Bay in the 1970s. The bay rests between two commercial areas where poultry farm secretes large amounts of manure and a change of factories that emit dangerous levels of nitrogen into the air. The Chesapeake Bay Foundation has made attempts to reduce pollution into the body of water. However, a dead zone still remains to this day.
Economic impact. Dead zones can have a severe effect on the economy, particularly on the fishing industry. In the past year, the GDP for the fishing industry was greater than $30 billion. As stated previously, when a dead zone occurs, it suffocates the marine animals in the affected area due to the low levels of oxygen. In 2013, the dead zone in the Gulf of Mexico was twice the size of the dead zone from the previous year. In that area, seafood is a $2 billion industry. Many small businesses take huge hits when these dead zones occur. And should this become the norm, with the size of the dead zones ever increasing, it can lead to a huge rise of unemployment in the fishing industry.
Is hypoxia reversible? The answer is yes. In the Black Sea, rise in fertilizer prices caused drastic reduction in usage, causing an unintentional drop in nitrogen levels in the Black Sea. In the North Sea, reduced sewage and industrial emissions resulted in 35% reduction in nitrogen levels in the North Sea. In the Hudson River and San Francisco Bay, a reduction in nitrogen levels were found due to cleanup efforts. Hypoxia prevention. We can use less fertilizer and find more environmentally friendly landscaping techniques. We can conserve water to reduce the volume of wastewater entering our rivers and streams. We can use safe and non-toxic alternatives for household cleaning and pest control. Build water treatment plants. We can find a better alternative to sewage systems and learn to compost our waste. We can find a better practice of discharging chemicals